As I just mentioned, the r squared is going up slowly, and it kind of goes up at a slower and slower rate. It doesn't have to do this, but with less variation and less significant variables, it's highly likely that we won't see any more big jumps in r squared unless we somehow hit a lucky split. Even then, the split before it might not have been significant, so we might be taking a wrong path. Going down here, there's two ways we generally end the tree. One, the software will end it for us, and we can't click the button anymore to split. But you don't want to get to that point. Generally, we'll decide to end the tree, and the splits will become insignificant. We see here tailgating and Gangnam Style predicting gender. And I really don't think these are significant predictors. I know that we have 11 males over here, and it looks like 3 females and 2 males, but I don't really think these are actually predicting. I think this was just a type 1 error. We found a variable we say is significant, but it's really not. We have the interpretation again that we talked about before. Look over this page, very important. So we have the leaf report. Good page to look over and know how to read a leaf report. We can save the predicteds to see just what the probability is, and you can even use this for new data sets to see if it's probable that someone from a new data set would be a certain variable, in this case male or female. We have usage and validation right here with r squared holdout. Generally speaking, you want to use this because it'll validate your model, and as in you can prove that it works on outside data. If we bring in new data and test out our model, will it work? And the best way to do this is with r squared holdout. We went over in great detail in class, but I won't be going over it in that much detail in this video. Good slides to just read over. R squared holdout is generally 25%, or it can be up to 40%. I talked to Dr. Seaver, and he said the research has not been totally done on this to tell them exactly what it should be in what circumstances. But the point of this is this. As I mentioned before, r squared holdout is an external validation. It is just like r squared. R squared is how well your model works on the data. R squared holdout is how well your model works on new data. So in other words, in our original data we're explaining 45.6% of the variation. In the data we're holding out, we're explaining 37.6% of the variation. Now there's other names you might hear for it out there. It could be called r squared validation or the training r squared for the original. But it says training here because it's using that training data to make the model, and then this is the validation data. We generally just call this r squared and r squared holdout because this data was held out from the original model. As you can see, 554 were in my original model and 176 were in the held out model. So once again, really comes down to collecting your data. Some of the basics we did at the start of this class are extremely important. One strategy when making trees is to find out what the most significant predictor is, it's right here, and then make a tree with that by just splitting, and then removing that and making a new tree. Because then what you're doing is you're creating a new path, because that first split controls where the tree goes. If we split on height, every split from then on will be controlled by height. We'll go back here and look at this for a second. But if you notice, the splits are within each split. So this split contains the next splits. And so we don't want to have a bad start path. If this original start path was bad, then it could lead us down a very wrong way. So one way to counteract that is to make multiple trees and find out which one you think via intuition best explained your data. Let's say they all have r squareds that are very similar. You might use other ways to sync which one you like best. And you could use the r squared holdout to see which one works best on the new data. You could make 5 trees and see which one has the best r squared holdout. A lot of good things to do. I love this chapter. I love this material. Very powerful tools in statistics. And that is everything. Good luck.